Hi, wonderful students. Now I'm going to talk about domain and range. So recall, we have functions. Functions are items, they're collections of ordered pairs, such that for every input there's a unique output. So here is a collection of ordered pairs, all the points that lie on that line. The domain is the set of all inputs. Okay, and the range is the set of all outputs. Okay, range, set of all outputs. Well, roughly, we can think of this as the set of all x's, and this one as the set of all y's. Well, what x values do we pick up on this line? Every single one of them. So this one's easy. This one is the set of infinity to infinity. You could say x is an element of the set of all real numbers. So that funny e is an element of. It belongs to, and then that funny r is the set of all real numbers. And then nice range is also infinity to infinity. Y is the set of all real numbers. But I actually think those ones where they're all real numbers are almost too easy, and then it makes it hard to understand the ones that aren't that interesting. So let's go to one that's like a more interesting graph. Okay, so I'm going to try a different color here. If I have this set, okay, this is just a line segment, and let's say that line segment goes between 0 and 1 for the x values, and for the y values, it's always at 1. So what is the domain? Remember, it's the x values. The x values are between 0 and 1. That's it. It is inclusive. I put solid dots on the end points, so you include the ends. And then what is the range? Well, this one's a little bit confusing because there's no interval. It's just simply y is the value 1. That's it. That's all you get. Domain and range. Okay, let's try another one. This time, let's go, here's my graph for the domain on this. What you need to do is you need to look at the graph as if there was a light shining up and down from the bottom. And then look at where the shadow would be. Where would that shadow be? It would be here on this x-axis. Let me program my writing. So here on the x-axis. Everywhere that there's a shadow, that's in the domain. So this is called a projection. So you project this onto this axis. Everything between 0 and 1 is clear, because that was a lot like this one. But then shadow up here, everything between 1 and 2. Now, if it didn't have this closed dot there, you would have an open, you would have no value, no x value at 1. But because this one created a shadow right there, what we picked up is, let's just draw this like this. So I put a shadow down here. This part of the line has a shadow on it. And I put a light from down here. And going up here, this part of the line. Now this is solid because this was solid. So the domain there, you can't see it real good, but this was in orange. Maybe you can't see it, I can't tell. The domain is between 0 and 2, and those are brackets. We include the boundaries. Now, let's erase some of that because it's getting a little messy. Now, let's look at the range. The range, same sort of thing. You're going to ask yourself, what y values does this graph pick up? Okay, let's see. Let's cast a light from this side and look at where does this shape create a shadow on this y-axis. So I would say the highest value is like it's 0. See, this is a solid dot here, all the way down there. Now look, there's no values between here and here. This was a solid dot. So when I go to write the range, it's going to be disjoint. I'm going to come down here. This is an open dot because this one is. And then all the squiggles going down to there. So where I put squiggles, that is the range. So here, I'll write it down here low on the board. I've got the lowest value was -2. And then I went up to -1, but -1 had an open dot on it, so I put an open parenthesis. And then there's no y values between -1 and 0, so I have to use the union symbol. And I go over to 0 and up to 1. Now, just in case that was too low on the board, I'm going to rewrite it up here. My range for that one was -2, let's use a darker pen, comma, up to -1, which that had an open dot on it, so I'm going to use a parenthesis. And then I'm going to union, that's union indicates that it's disjoint, it is two separate sets, up here to 0, comma, 1. Okay, so a bracket because we had a solid dot on the lowest point, an open parenthesis because there was no value for x or y equals -1, and then a solid dot here, which means it's a bracket on 0, and then all the way up to here, which is a parenthesis. That's the range. Okay, so now we've got a couple nice examples of domain and range. Let's do one more. Domain, they're all the x values. How far left and how far right. So remember, this is the x's. How far left does that arrow go? Well, that arrow's going to go clear out there, -infinity. How far right does it go? It's going to go clear off to the right. It's going to be +infinity. Okay, those are little sideways 8s. Okay, let's do the range. Remember, the ranges are, I can change pens because it's getting a little weird. Okay, those are the y's. This is how far low, comma, how far high. You do the small numbers first. Let's say this is at 1. The lowest value then is at 1. Oops, that +1. Ooh, my markers are making a mess here, but that's okay. 1. And then how far up does it go? Well, it goes to infinity. Okay, so when you do these domain and ranges, domain, you're asking yourself how far left and how far right. You can think of it like I did with a projection onto the x-axis. Range, how low to how high, and again, you can think of it as projections if you want, if that helps. For me, I just think of it as a moving, like how far left and how far right. How low, how high can I go? Okay, I know I'm running out of time here, but I want to do one more. What if I had, this is one that went like this. Okay, the domain is still infinity to infinity, and the range, let's see, again, what I want to practice here is the order. How low does it go? Well, it goes to -infinity. How high does it go? Well, it hits a ceiling. It's like putting a hat on. It does not get any taller than y equals 0, right there. Okay, so that's it for domain and range. So it's a really important concept. It carries to all your other math classes. So I really want to have you guys get it right now. Okay, good job.